Okay, we're going to talk about the last topic for Chapter 12, which is 12.6, normal distribution, right there. Otherwise, you probably know it as the bell curve. Normal distribution is just like the bell curve. And your essential question today is, I can find the probability of an event given the data is normally distributed and its mean and standard deviation, which we know how to calculate now, are known, as well as use z-scores to find probabilities. Okay, it looks like there's a lot to do this learning target right here, or this learning target. So let's just get going on this. First off, the question is, what is a normal distribution and what does it look like? Well, a distribution that tends around a central value, like if the average was this, but the distribution tends around it, kind of goes towards it, with no biases to the left or the right, is said to be normally distributed. And here is a picture of what a normal distribution might look like down here. It's a bell curve, and there's a lot of things going on here. I'll explain them later, but I'll give you an example of maybe something that might be normally distributed. And not all the cases, but let's just say the height of male students in a school could be normally distributed. And let's say maybe in this situation the average height was 68 and the standard deviation of that height goes up by 3 inches either direction. Each standard deviation is 3 inches. Well, we can actually use this information to start to gather the percent of students, if it is normally distributed, that would fall within certain ranges right here. So in this situation, 68 is our mean. So our average, or median, is 68 right there. Mean, median, average, they're all actually the same thing. The mode's even right in the middle too. Okay? And the standard deviation is 3. Now, if the standard deviation is 3, each of these lines represents an additional standard deviation. Okay? And you'll notice that within one standard deviation from the mean, 68% of the population will be within that one standard deviation. Okay? Within 2 standard deviations right here, from here to here, right here, 95% of the population is within 2 standard deviations of the mean, as long as that data is normally distributed. And lastly, within 3 standard deviations, almost all the data is within 3 standard deviations from the mean. Look at this, 97% of the data, 99.7%, is within 3 standard deviations of the mean. So let's fill this out using the information we were given up here. We know the mean, or the average, is 68, so that's the middle. And we know that each standard deviation is 3. So if each standard deviation is 3 inches higher or lower, then 68 plus 3 would be 68, 71. This would be 71. And if we went down, this would be 65. Because we're going up by 3, plus 3, down by 3, minus 3. And if we go down another 3, then we would go down to 62 for this one, minus 3. Minus 3, and we go by up, and then we're up to 74 plus 3 right here. And if we go up another 3, we're at 77 plus 3. And if we go down another 3, we're down to 59 inches tall minus 3. So if we look at this data and I were to say to you, hey, what percent of the students are between 65 inches and 71 inches tall? Well, you say, well, that's 65 to 71. Well, that's from here to here. Those are 1 standard deviations away. So about 34 plus 34, which is 68% of the students are within 1 standard deviation of the mean, or 68% of the students are between 65 and 71 inches tall. And that's how you read something like this, a standard deviation or a bell curve like this. We're going to move on to the next problem, and the next problem is going to talk a little bit of how you can use this bell curve a little bit more to solve some of these problems, and I kind of give you the gist of that already.